Hello everyone. So in this video, let's talk about the E problem from the Codeforces round 871. Problem named the lakes. You are given an n cross m grid of non-negative integers. You are given some grid. The value a of ij represent the depth of water in the ith, j, and row. So you are given some grid. Every block has some depth that is defined by that particular value in that cell. A lake is a set of cells. So a lake is called, let's say, a set, or you can say a collection of cells, such that each cell in the set has a of ij greater than or equal to 0, which means that a lake is somehow like all the values has to be greater than 0, and there exists a path between any pair of cells in the lake going up, down, left, right, from one cell to another, and without stepping on a cell that is a of I or j equal to 0. So as you can see, you can also understand with some examples as well, but in simple terms, you have seen lake, you have some land, and a lake is somehow like some water, okay, in some, let's say, surrounded by land. So you have also seen such type of problems as well, okay. So you have to find out some Iceland. So Iceland is, let's say, all other is water, and then you have some you can say some land. This is reverse of that. You have all, let's say, land is, let's say, defined by 0, and you have some lake has some water in that, okay, and every cell defines the depth of the lake. Let's say this is like 6 depth, 2 depth, 4 depth, 3 depth, and this is 0, which means that somehow this is some land and so on. So because 0, which means that there is no depth, which means that this is some land. Okay, that is somehow that is given to you. You have to find out the you can say the lake is the, so as you can see, the volume of the lake is the sum of the depth of all the cells in the lake. So the volume of the lake is the sum of all the values inside this particular value, like the thing that you have formed. Then find out the largest volume lake in the grid. Okay, so among all the lakes that you can form on the grid, find out the lake that is the largest volume. So this is somehow actually finding out islands in a grid of water. It's just that we have to find out lakes now, and for every lake, you just have to find out the sum of all the elements inside the lake. So it's a very standard problem, nothing much complicated itself. Let's see some example as well. In this, as you can see here in the first one, you have this as a complete lake, because this is surrounded by ones, and like this is 5, so that is also fine. This is zeros, and like this is land, and this is like again a smaller lake. Okay, this is a actual lake, and the lake consisting of the sum of all these values, that is 4 plus 7, 8, 9, 10. So the answer is 10. That's the maximum lake that I can form. In this, as uh, you can see that this is the maximum possible lake that I can get, and that is, as you can see, oh, okay, I can also include that as well. So I can form like this: 1, 2, 3, 4, 5, 6, 7. Okay, somehow that is the thing that we have to find out. And how you can do that? So it's a very standard problem. What we'll do is that we'll just do a DFS here. Okay, and from every cell possible, we'll start our DFS and try to find out that if this is a part of a lake that we are on. First, try to get the sum of all the values in a particular section that we have. Whenever we take a cell in a lake, make it 0, because we have counted that. If like we'll just do a DFS starting from every cell that is a non-zero value. So we'll start from, let's say, in this particular section, we'll start from the first block. This is a non-zero value. We'll start our DFS, which means that we'll try to go in all the 4 directions. And before going in direction, we will take this in the total sum, because we are trying to find out a lake total sum. So we'll take this as a total sum and try to go in all the directions, and again find out the total sum for all the directions. And whenever we take a complete cell, what we'll do is that, because we have taken that into the complete cell and we don't want to reiterate the same cell again and again, because we have taken that a depth, we'll make it 0. We'll make it 0, which means that I will make this as a 0, which means this is a land now. So that we'll not reiterate it, because we'll only iterate over the cells that has some depth. 0, we do not iterate. So if you have taken any cell into consideration, mark it as 0. It's a pretty simple and standard technique. So that mark it as 0, which means that I will not iterate it, but I have taken that into consideration into the lake that I'm forming, and I'll find out the maximum lake possible among this DFS. Well, I will show you the code part now, don't worry. And then we'll find out the maximum among all of them, among all the lakes that we found out. That's the only thing. If you want to watch out any more problems, that is finding out the number of islands, and like how many you can say number of islands that we have, or like that is a very standard problem. You can check online and you will understand how to solve this problem more. So what we have done is that this is the solve function. We'll first take the input of the complete grid. Then I want to maximize the lake. So what we'll do is that we'll do a for loop, and we will check that whenever we find out a non-zero value, which means that I can somehow potentially get a lake from there, because if it is zero, which means that I cannot find a lake. So if in the grid that we have, that is the A grid, if I somehow get a non-zero value, which means that I can somehow get a lake from there, we'll start our DFS from that particular point, which will be called using this calculate function, that is cal, starting from the ij value. This is the boundary, that is n comma n, and this is the grid that we have. We'll call this calculate function with these parameters, and this will return the maximum size or depth of the lake. This function will return, and I have to somehow like maximize it over all the lakes, because if this condition will only hit if we somehow get a lake, and if somehow get a lake, which means that I somehow get a of ij which is not zero, which means that I somehow get a depth in from the land, which means that I somehow get water, which means that somehow get a lake. So if I somehow get a lake, I'll start forming the depth, the complete depth of the lake that we have, and I want to maximize it among all the possible lakes that I can get. And in the end, we return the maximum lake depth. Okay. Now, what this calculate function will do is just a complete DFS. So DFS means that we are just doing a recursion. So for a recursion, we have to first check out the base conditions. Base condition is that if I go out of bound, return zero, which means that I cannot have anything as out of bound. So it doesn't calculate in a depth, so return zero. If I somehow land upon a land, you can see, or a zero depth cell, which means that I cannot count it again. It is like waste of us. We cannot go out of bound of the lake. So again, return zero. So these are just base conditions. Or else, if I am not out of bound and if I am not on land, which means that I am somehow on the lake part, I am on a cell that is including in the lake. So I am including that particular cell in the lake, the total depth that we have, and making it at zero. Okay, so this value is first added in the total, as you can see, and then removed. This is actually done so that we should not recount the same cell again, and it doesn't affect our total time complexity. Okay, we can also maintain a visited matrix and try to check out what all blocks that we have already visited. Don't revisit it, because in DFS we don't want to revisit a complete block, because I'm trying to find out a lake. That is also done, but that is also a very classic technique that you can do, so that you can do it in the same, you can say, matrix that you have. Count that particular cell and make it a zero. Okay. Now we have taken that cell in the total count. Now we have to do the DFS again, like the start the recursive in all the four directions: top, bottom, left, and right. So I'm doing the calculate function again with all the four directions again, and incrementing what is the depth that I can get if I go in all the directions, because I can find out the lake in all the directions that I have. And I will add the total among all the directions, total lake that I will get. Okay, and then return the total. Okay, that's the complete DFS recursion part to get the depth of all the cells in a lake, and that is how I will get that, and I want to maximize it among all the lakes that I will get. Okay, that's a complete logical code part for this particular problem. If you still have any doubts, you can mention on in the comment box for this particular video. I'll see you next time. Link coding, and bye.